Thank you. Good morning. And thank you all for being awake this morning after the party last night. I appreciate you being here. Today, I want to talk to you about threat modeling lessons from Star Wars. And really, there's three main things I want to talk about. I want to explain what threat modeling is. I want to cover a simple approach to threat modeling, share with you top 10 lessons that I've learned over the years in helping people at a wide variety of organizations learn to threat model more effectively, and then give you some resources to learn more. So to start out, what is threat modeling? Threat modeling is something we all do. It's about abstracting away details so that you can think about the threat. If I asked you to threat model a house, if I asked you to help threat model my house, you might think about someone who's going to break in and try and steal the stereo. You're probably not going to worry about what color shirt they're wearing as they do it. You're ignoring irrelevant details to focus on a model. You might also think about it in terms of access points like doors and windows, and use that as a basis for understanding how someone might break into my house. And your threat modeling. Over the years, we've created a lot of complexity in the way in which people instruct you to threat model when you think about software. I think a lot of that complexity takes away from our innate ability to do these sorts of tasks and to apply this sort of thinking. And so I like to think about a simple approach to threat modeling. And this simple approach boils down to 4 questions. The first question is, what are you building? The second is, what can go wrong? The third, what are you going to do about it? And then finally, did you do a good job at numbers 1 through 3? This is really simple. It's something that everyone involved in a software project, in a systems rollout, or in any other bit of technology should be able to answer. You can say, we're building this. You go to a whiteboard, you draw a picture on a napkin. That's the start of the what are you building question. The question of what can go wrong, we all have intuitive answers to that sort of question. We know that things are going to go wrong with the software that we build. And the interesting question to me is, how can we get systematic about thinking about what can go wrong? How can we go from intuition to some sort of structure so that when you threat model and you threat model and you threat model, we come up with reasonably similar answers so that we can say, yeah, we did a good job or we didn't do a good job, because everyone's intuition might be different, and that's why we look to frameworks. And so before I go to questions 3 and 4, I want to share with you a framework that I find to be very useful, and that is STRIDE. STRIDE stands for Spoofing, Tampering, Repudiation, Information Disclosure, Denial of Service, and Elevation of Privilege. Now that you know that, we're ready to move on, right? No, let's go through that a little bit more slowly. Spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. These are threats or attacks that recur over and over again in all sorts of software projects. Box software, web services, websites, mobile apps, all of these suffer from these sorts of problems. And to help you remember these, I have a few examples from Star Wars. So spoofing is anything from Luke Skywalker pretending to be a stormtrooper, through someone pretending to be PayPal.com or a Nigerian prince with money to give you. Spoofing might be, here's a copy of NTDLL, which isn't really that. There's all forms of spoofing attacks which involve confusing or impersonating one party to another. So the S in STRIDE stands for spoofing. The T in STRIDE stands for tampering. And whether that's Ben Kenobi turning off the power to a tractor beam, or somebody modifying packets on disk, or packets on the wire or bits on disk, each of these is an example of modifying something that you shouldn't be modifying. So the T in STRIDE stands for tampering. The R in STRIDE stands for repudiation. And that might be Han Solo declaring that there's been a reactor meltdown, very dangerous, because he doesn't want the conversation to continue. It might be saying, I have no idea who ordered that. It might be saying, I'm sorry, I didn't get your email. It must have been eaten by a spam filter. Whether it's true or not, each of these is an example of a repudiation of some action which might or might not have taken place. So the R in STRIDE stands for repudiation. The I in STRIDE stands for information disclosure. And whether what's being disclosed are the plans for a battle station, confidential information about your stock performance, or metadata, information disclosure is all about information that's not authorized to be out there in some way. Now, if you're paying attention, and I know it's early in the morning, but if you're paying attention, you might notice that I don't have a Lego version of this. And the reason for that is because a lot of people, actually, let me ask a question here. A lot of people think Star Wars is about Luke's journey into manhood. Anyone believe Star Wars is about Luke's journey into manhood? Yeah, thank you. We've got at least a couple. How about Luke's relationship to his father? Okay, we've got a few more, and I'm sorry, but you're wrong. Star Wars is the story of information disclosure. From the very opening scenes, where we see Princess Leia's ship being pursued, through to the climactic battle at the end, Star Wars is all about information disclosure and its consequences. I urge you to go rewatch the movie in that light. I think you'll enjoy it a lot. So the I in STRIDE stands for information disclosure. The D in STRIDE stands for denial of service. And whether that's freezing Han Solo in carbonite, whether it's sending millions of packets to a server so that the legitimate ones can't get through, whether that's a zip bomb filling up a hard drive, all of these are about destroying access to some resource or limiting access to some resource. So the D in STRIDE, denial of service. Elevation of privilege, whether that's Ben Kenobi saying these aren't the droids you're looking for, someone finding a hidden admin interface, or perhaps, I don't know, sending a few bash commands to your web server. Each of these is an example of elevation of privilege, doing things that you're not authorized to do. And so STRIDE acts as a framework, a mnemonic for helping people think about the question of what can go wrong in the system that we're building or the system that we're deploying. So questions 3 and 4, what are you going to do about it, and did you do a good job? Frankly, I don't have great Star Wars examples from those. What are you going to do about it? The right thing to do is file bugs, track what it is you learned, and go deal with it in the same way you deal with any other issue in the systems you're building. And did you do a good job? Do some QA, look through what you've done, but rather than focus on those, I want to actually share with you 10 lessons that I've learned along the way as I've threat modeled, and more importantly, as I've worked with organizations that have tried to threat model and not succeeded. And the reason that I want to share these is not to point a finger and laugh at those organizations, but because the mistakes that I've seen over the years fit into categories. They fit into repeated patterns, or as it were, traps. And I'd like to explain to you each of those traps, how you can discover that you or an organization that you're helping is in one of those traps, and help you get out of it so that you can threat model effectively. So the first trap is something that we as security people are taught to say. I've said this for years. It's think like an attacker. And the trouble with saying think like an attacker is a lot of people have no idea how to do it, but they're embarrassed to admit that when you say it as if it's an obvious thing. So I like to say think like a professional chef. Because even if you love cooking, even if you're an enthusiastic home chef, if I asked you to plan a menu for a restaurant with 50 seats and asked you how much food you should buy to minimize waste and maximize your profit, you'd probably have no idea how to go about answering those questions. A professional chef knows how to do it. If I walked you through it, you could probably learn, but most people need structure and the exhortation to think like an attacker, excuse me, doesn't help you understand what you need to do unless you already know. And so thinking like an attacker can be a trap. The second trap is to say you're never done threat modeling. And diagrams like this, which I'm responsible for this being in a lot of Microsoft's threat modeling documentation. My friend Andy Jakewith likes to call this a hamster wheel of pain, because you get onto it, and then you go around and around and around, and you don't get somewhere useful. And the reason that this is really a trap is, let me be optimistic and say I go to your VP of development or your VP of operations and say, for this project that you're doing, I would like you to add threat modeling to the process. Let's be optimistic, and she'll say, great, I'm happy to do that. And then she'll ask, how long will it take? I say, you're never done threat modeling. And she'll say, great, the door's over there. The problem is, if you're never done, it doesn't fit into a project schedule. And so rather than thinking about this as a hamster wheel, I like to unroll this loop and think about it as a linear process. And these 4 questions, or these 4 stages: model, what are you building? Identify threats, what can go wrong? Mitigate, what are you going to do about it? And then validate, did you do a good job? These are the same 4 questions, but thinking about it as a linear set of steps rather than you're never done helps an organization pick up and execute on these processes. So the second trap, you're never done threat modeling. The third trap is to say the way to threat model is. And this is another trap that I've personally fallen into, where I get very focused on the way to threat model is stride with this type of diagram, because I've seen that work for lots and lots of people. But I've also seen other approaches work well for people. And so now, rather than saying the way to threat model is this or that, I'm much more focused on what helps people find the threats that they care about. And I'm also focused on a question of what helps lots of people. I'm really excited to be here at BruCON with a set of security professionals, but you're not always the people who are building software. I'm really focused these days on how do I help the people who are building software, who are building new systems, who are deploying those systems think about their threats, because they make decisions without us in the room. And if we don't give them ways that they can make decisions, we don't give them ways that they can understand what's going to go wrong, then they're going to make decisions without that security knowledge, and then we're going to come in and say, oh my gosh, you made this big mistake, we have a big problem. And odds are, unfortunately, we're going to do it towards the end of their project, and it's going to lead to a lot of conflict that we can avoid. So rather than saying the way to threat model is, I like to borrow a line from the Perl folks and say there's more than one way to do it. And because there's more than one way to do it, I no longer think about this in terms of monolithic processes. You might have thought that the Legos earlier were just a fun little thing, and they were, but also I think about threat modeling as a collection of building blocks, a set of things which we can snap together, and we can actually construct different ways to threat model out of composable pieces. And if we go from a monolithic approach to a composable approach, then it gives us a couple of advantages. 1, we can experiment more easily. 2, we can adapt more easily. So we might use data flow diagrams as a way to model. And data flow diagrams consist of processes, data flows, data stores. And they're what's used in a lot of threat modeling work because threats tend to follow the data flows. So data flow diagrams are great. But if you're threat modeling a networking system, you might want to use swim lanes, those long diagrams which show packets moving back and forth between systems. When you're identifying threats, stride is great. for many people, and I'll talk about for whom it works, but there's other systems. There's a library of threats from MITRE called CAPEC, the Common Attack Pattern Enumeration and Categorization. You can use attack trees, and each of these can slot in with different types of diagrams. You can threat model for privacy as well. You can substitute in something like contextual integrity instead of stride. Contextual integrity is a system that says most privacy violations happen when the expectations in a context are violated. And a context they borrowed from sociology, where, for example, going to your doctor's office is one context, speaking at a conference is another. There's different expectations and norms of behavior at each of these. If I go to my doctor and say, hey doc, I have this rash, and my doctor says, oh, well, that's interesting, and asks me some questions, and then goes in the other room and makes a phone call to another doctor for some advice, that's perfectly normal in the doctor's office. If I run into my doctor at the supermarket and she said, hey, Adam was telling me about this rash he has, what do you think? That would be weird. Same people, same conversation, different context. And so the approaches that contextual integrity offers allow you to threat model for privacy. Similarly, Dan Solove, in his book Understanding Privacy, puts forth a categorization of privacy harms. You can use that with a data flow diagram, with another diagram, to find privacy threats. Similarly, there's different ways you can address threats, there's different ways you can validate. And so you don't have to think of these things as monolithic. You can think of them as things that may well compose together. Not everything will compose, but a lot of threat modeling parts will. So I've alluded to this a little bit, but different approaches to threat modeling work for different people. For example, for many of you, you can sit there and use stride as a way to go through what's going to go wrong. But if you're a database expert, if you're a networking expert, you might not have examples of information disclosure at hand. You might find yourself wanting a more precise, more drawn-out sort of approach. CAPEC has detailed descriptions of different types of threats. So for example, it will tell you that SQL injection tends to occur with databases and database front ends. This is how to test for it, this is how to correct it, and it's a very organized, systematic approach that, meaning no disrespect to the folks who created it, many of you might find a little tedious to go through. And the reason you'll find it tedious is you know a lot of the information that's encoded within it. But if you're expert in something other than security, CAPEC can be a real value add for those people because it provides the knowledge that you've absorbed through conferences like this. Attack trees, somewhere in the middle. They're useful. Creating attack trees can be very hard, but using them can be a little easier. There's one other thing that often comes up when we're talking about lists of threats or organizing threats, and that is checklists. People say, can I just have a checklist of everything that might go wrong for my application? And the answer is, if your application isn't doing anything new, then yes, we can give you a checklist of everything that might go wrong with it. But you're writing new code to do new things, or you're composing pieces in new ways to do new things. And that probably means there are new threats. Now, I used to really hate checklists completely. And then I read this wonderful little book called A Checklist Manifesto by Atul Gawande. And if you hate checklists, you should take a look at this book. It's an easy read, it'll take you an afternoon. And what I learned is that checklists apply in certain situations, which is when there's a common set of things that go wrong, that's limited in scope, maybe 5 or 7 items, and each can be judged quickly, a checklist can be a great thing to use to help you make sure you're not making a mistake. So for example, you're landing a plane. Is the landing gear down? Are the flaps in the right position? Have you contacted the tower? You're good to go. That doesn't tell you how to fly a plane. It just tells you these are common things that are going to go wrong. that people skip over and don't remember. So you can use checklists as part of threat modeling. Did I look at this? Did I look at this component? Did I think about this threat? Did I think about tampering? Did I think about information disclosure? But they can't replace threat modeling. So trap number 4 is to think about threat modeling as a single skill. Do you understand how to threat model? There's different sub-skills within that. Drawing a great diagram, which really helps people see what's likely to go wrong, is a skill in and of itself. Remembering, understanding what spoofing attacks are likely, what tampering attacks are likely, how to draw an attack tree. Each of these is a separate skill. And if you think about threat modeling as a single monolith, as a single skill set, then it becomes very, very hard to teach. It becomes very, very hard to learn because there's so much that's wrapped up in what you're calling one thing. You break it down, it makes it more accessible. So there's techniques, there's also repertoire. The knowledge that we accumulate through conferences, through conversations over beer about what's gone wrong acts as a repertoire, and you can draw on this, and someone can say, well, how would someone do this? Is that easy to do? Well, yeah, it's easy to do this. I can take SSL out with SSL spoof. I can use Firesheep to steal your web cookies. And you acquire this knowledge over time. And I think one of the things which really distinguishes experts is not this idea of inborn skill or thinking like an attacker. It's the knowledge that we accumulate, the frameworks that we put it in so we can come up with the answers quickly and apparently intuitively. And a lot of experts I know threat model in ways that I find don't work for me. For example, they start from a list of attackers, and then they come up with all these great attacks. And they try and teach other people, and the other people struggle. And what I've come to believe is that they're using these attacker lists as a framework, as a mental tool to help them remember what's going to go wrong in a given situation. And that the techniques that I as an expert might use and the techniques that a beginner might use might be very different. So threat modeling isn't a single skill, it's a combination of skills. And as a combination of skills, there's this belief that when people get good at this, that it must have been inborn. It's not inborn any more than playing a violin is inborn. And if you hand me a violin, and this is a mistake, you should not do this. But if you were to hand me a violin, I can't make music with it. But if I sat down with a violin teacher and I learned the fingerings and I learned to use the bow over time, I could make it less painful for the other people in the room. But what that teacher would do would be give me easy tunes to play. He wouldn't start me off with like Bach violin concertos because they're simply too difficult for someone who's new. And so we need to give people manageable problems as they're getting started. And we need to recognize that not everyone wants to be a virtuoso. Not everyone's goal is to play in the orchestra. I have a lot of friends who are weekend musicians. They enjoy playing with pickup bands. They have fun, but they have no aspiration. They don't have the time to really become an expert, and that's an okay thing. And I think if we think about threat modeling as something which can be taught, where different skill levels in different things are possible, then we get a lot more out of the people that we're working with. We get a lot more out of our organizations than if we demand that everyone be a concert-level violinist in order to participate in security work. So trap number 5, thinking about threat modeling as something that's born, not taught. So as Lando Calrissian says, we've got to give them more time. Trap number 6 is the wrong focus. And I'm going to walk through these one by one rather than putting them all up on screen, because a lot of what I'm going to say might be a little shocking or confrontational for some people. And I apologize, I don't mean to confront anyone's ideas as much as examine them. And the first focus that I think is wrong, and I think it's wrong because, and I'll explain why, is to start from assets. And starting from assets seems so logical that it's hard to argue with. If you don't have any assets, why would you be threat modeling? If you don't have anything to protect, why go through this exercise, right? Seems logical. The reason that starting from assets is a trap is twofold. The first is the question of what is an asset. So you might start out and say, well, our money, our reputation. And then you go through and say, well, where's the money? The money's in the general ledger. And then the money is in every system that connects to the general ledger. And then the money is in the developer desktops that can change the systems that connect to the general ledger. And so you end up with these disparate things like the general ledger and the reputation, and everything is an asset. So you make this list, which is very apples and oranges, and what do you then do with it? Where do you go? You say, well, how could someone attack this? And then you draw a diagram of your system, and when do you use that asset list? You use that asset list when you're evaluating threats, when you're saying, does this matter? And so when you start from assets, you do this exercise that's complicated, that's failure prone, that has definitional issues, and you use it much later in the process. Whereas when you come to a system and say, this system right here is their general ledger, do we care about people tampering with it? Yeah, we do. You can use your assets later without having created a comprehensive list at the start. So I don't like starting from assets as a way to threat model. I also don't like threat modeling from a list of attackers. And I don't like starting from a list of attackers, again, for two reasons. First, because you might get the list wrong. You might forget an attacker that's going to come after you. And secondly, you might misunderstand what those attackers are going to do. For example, I had the interesting experience of having an office mate for a while who worked for the FBI's counterintelligence division. And I really like spy novels. I like John le Carré novels and stuff when I fly. And so I had this picture in my head of how Russian spies operate. And it turns out that my office mate, Chris, knew how Russian spies operate because he used to help catch them. My model was completely off base. And so if you start from a list of attackers, you might have the wrong attackers, you might have the wrong attacks. Whereas you might also say, well, attackers can be useful in threat modeling. And the place that attackers are useful is when someone says, well, no one would ever do that. And that's when you can whip out your list of attackers and say, well, actually, Anonymous did that last year in this way, and that's why you should care about that. Or you can get even a little bit more clever when someone says no one would ever do that. What I now like to do is I like to say, if I can explain to you who would do that, will you agree to fix this issue? And the reason I ask that is because oftentimes people say, no one would ever do that. What they mean is not no one would ever do that. What they mean is, I don't want to bother fixing this thing. And so we're going to have an argument that no one would do that. And by asking the question, will you agree to fix it? You can end up having a much more productive conversation about, is this the cost of fixing, or is this really the belief that it's not going to happen? Another wrong place to focus is thinking that threat modeling should focus on finding threats. This is also pretty natural. It's called threat modeling. Why wouldn't it focus on finding threats? And the answer, and I'll talk more about this in just a second, but the answer is you should focus on fixing these problems. If you just threat model, you create a list of threats, you don't do anything about it, what's the point of the exercise? And so it's easy to get trapped there. It's easy to get trapped in the way to threat model is, rather than get focused on what's going to go wrong and what are we going to do about it. And I should just mention, there are people out there, there's probably some of you in the room, who start from assets, who start from attackers, and it works for you. Great. Don't change. Maybe experiment. But if it's working for you, who am I to tell you that it's the wrong thing? There's more than one way to threat model, and to the extent that it works, have at it. Trap 7 is a trap that I'm not positive how we get out of, but it's an important trap and one that I want to think about over the next few years, which is that threat modeling is for specialists. If a developer came into my office and I was interviewing them for a job, and I said, tell me about branch management in Git, or if I was being nice, tell me about branch management in Subversion. And they said, well, I've heard about this version control thing in branch management, but it's not for me. I write my code once and that's it. I'd say, thank you very much. It's nice talking to you, and have a good day. Because every developer knows how to use version control. And when I was a sysadmin, I used version control as a way to manage the system configuration files. I would like threat modeling to be at that point where every developer, every sysadmin knows the basics of threat modeling, understands how to ask what can go wrong and what are we going to do about it in a comprehensive, systematic way. And this is a stretch goal. I'm optimistic that we can get there through simplifying it, through identifying the traps that we need to consider, and by teaching it in new and easier to access ways. And if we can make threat modeling that accessible, I will consider it a huge victory for security. So trap number 8 is thinking of threat modeling in a vacuum. And so there are threats that are easy, and I say easy in quotes, for a developer to fix. If there's business logic in your code, you can log what the business logic is deciding and why. But once that code is compiled and ready to deploy, you can't figure out what the business logic is doing. Zaz talked about this a little bit yesterday in saying that complex adaptive autonomous vehicles do things that surprise their creators and designers. And if you don't have the right logs, you can't figure out why it did the thing that it did. There are other threats that are easy for operations people or easy for hardware developers to work on. And at each point in the supply chain, it's great if we can think about what threats we're going to address and communicate those along the chain. And there's some tools that help you do this. I like creating security operations guides for my software early. The reason I do that is because a security operations guide is a model of what we're going to use the software to do, and it's a model of what we're going to ask a sysadmin to manage. And I can write that guide and I can bring it to someone and say, could you do this? How much would it take to make this a part of your operations? And usually what they say is, ha ha ha, this is funny. You need to simplify this and this and this and this because it's just too much work. You can also use non-requirements as a way to communicate about your threat model. For example, Microsoft has 10 immutable laws of security, which are really all about the threat model that Microsoft software tends to follow. If someone can run software on your computer, it's not your computer anymore. You might agree, you might disagree, but that's the threat model that the software creators have. And by saying these are the things that we will and won't do, you can decide whether or not that's the right model for you. So if you think about threat modeling not as something that happens in a vacuum, but something that happens as a point in a supply chain, you'll do well by that. So don't threat model in a vacuum. Trap number 9 is a laser-like focus on threats. There's this interplay of attacks, mitigations, and requirements, and I'm going to talk about each. The first is requirements drive threats. So for example, if someone were to say, the plans to this battle station must remain confidential, then you know that information disclosure threats are important to that organization and they have to be dealt with appropriately. You might go from the other side. Maybe the empire employs a bunch of open source advocates who say with enough eyes, all bugs are shallow. Or maybe they say with enough eyes, all trenches are shallow. I'm not sure what they'd say. But that might drive a conversation about what the requirements really are. Do we need to keep the plans to this battle station confidential? I don't know what the right answer is, but I do know that you can start from requirements or you can start from threats, and they play off each other to help you understand the other. Similarly, there's an interplay of threats and mitigations. If I have a door that I'm worried someone will go through, I can put a lock on it and then I'm done, right? No, obviously not. I put a lock on it and then I have to worry that someone's going to pick the lock, they're going to kick the door down. And so I put an alarm on the door. And then I have to worry that someone's going to cut the alarm wire or otherwise tamper with the sensors. And if I'm thinking clearly about the house as a whole, I have to say, okay, am I overly focused on this one door when there's a back window that doesn't close because it's been stuck for years and someone can just climb through it? And so there's an interplay between threats and mitigations, much like there's an interplay between threats and requirements. Lastly, there's an interplay between mitigations and requirements. If I have a threat that I can't mitigate, for example, I might want to talk about defending against my systems administrators and say that every activity on some system requires a two-person rule where someone takes an action and someone else approves it. It's hugely expensive to develop software that does that. It's hugely expensive to operate. And so I might declare that if your administrator is untrustworthy, you're out of luck. And once I've done that, and I've said that I have a non-requirement that I can't mitigate this, so I'm not going to try, then I free up security effort to focus on other problems. I change my requirements, and then I develop in accordance with those new, clearer requirements. Now, you might notice over here that I have a dotted line from requirements to mitigations. And the reason I have a dotted line from requirements to mitigations is because when I drew this little model to help clarify things, it was all symmetrical except that one line. I couldn't figure out what that line was until I realized that a requirement to deploy a mitigation or a control without the presence of any threat is an excellent description of many compliance programs. And maybe that's a useful explanation of why so many people are so skeptical of compliance programs. Now, one other thing I want to say about this is since Ed Snowden started to reveal information about surveillance activities by governments, it's become super fashionable to say the threat model has changed. Right? Have people heard this? The threat model's changed? I'm getting a few nods. So with all due respect, I believe that perspective is wrong. If your threat modeling approach did not tell you that eavesdropping on an unencrypted network was possible, it was a crappy threat modeling approach. If your threat modeling approach didn't tell you that people might try and exploit your system to understand what your computer is doing, it was a bad threat modeling approach. What's changed in the last year and a little bit, is that we care about the requirements to defend against those threats. So what's changed aren't the threats, it's the requirements. That may sound a little niggling, it may sound like I'm nitpicking. And the reason I think it's important is because if you're focused on the threats changing, you might not realize that the business requirements having changed really means that the business requirements have changed and we need to go back and understand what the new requirements look like so that we can defend against them properly. So it's another aspect of the way in which attacks, mitigations, and requirements play against each other. The last trap is threat modeling at the wrong time. You don't want to be like this guy coming up and saying, "Sir, we've analyzed their attack pattern and there is a danger." He had a bad day after that. You want to threat model early while your Death Star is in space dock or dry dock or whatever they call it. You want to think about it because maybe you can put a plate over that thing. Maybe you can not build trenches that lead up to your thermal exhaust ports. There's lots of ways you might fix this problem, but you can't do it in the middle of a battle. And so you need to threat model while you're conceptualizing your software, while you're thinking about what your new designs are going to be, while you're thinking about what the deployment will look like. You need to threat model then. So those are 10 traps that people and organizations fall into that make it hard to threat model. And I've been speaking a little quickly, so I have a few tricky areas, and I'm going to talk about one of them. And what I want to talk about is human factors traps that people fall into. And it's popular for security people to say, given a choice between security and dancing babies, people will pick the dancing babies every time. I see some of you grinning, I see some recognition, and unfortunately, this is something we often say with contempt, as if people buy their computers to be secure. No, they buy their computers to stay up to date with their friends on Facebook. They buy their computers to get some job done. They don't buy their computers to stay secure. And so, I believe that we need to use models of people to think about the ways people will predictably behave to help us build more secure systems. And I might use a behaviorist model. The behaviorists, Pavlov, the dog salivating at the ring of a bell, people are trained they're conditioned to act in certain ways. So if 50 times a day, some program pops up a dialog box that says, hey, this file might be dangerous, you're going to get into the habit of hitting OK, continue very, very quickly because you're being asked to do this thing over and over again. And you know, we can predict that that's going to happen. We can use cognitive science models. Another book that I would highly, highly recommend, Daniel Kahneman's Thinking Fast and Slow. Wonderful book about how the human brain works. And in it, he talks about this phenomenon that he calls what you see is all there is, that it's very hard when there are things happening in front of you to think about abstract things or rules or other things that are not present. And so, if we think about something like a security model for the web browser, where we have indicators of security that appear and disappear, or move around on the screen from version to version, we can predict that when they're not present, people won't be thinking about them, and they won't think that this is an insecure connection. So we can use these models of people in our threat modeling approaches, and you can add people to your software diagrams. You can say, hey, this system talks to this system, and that system talks to this person. And when it does, you can ask, what are you communicating to the person over here? How is the software communicating that information? And what do you expect that person to know? And those are simple questions. They're not complex questions. While I recommend Kahneman's book, you don't need to read it to ask either of those things. But you will often discover one of two things with those two questions. First, you're not communicating essential information that the person needs to make a decision that you expect them to make. And when you ask, what decision are we asking of them? What do we expect them to know? You will realize that as you try to make it explicit what you're asking, that the information is simply not present, or the information they need to make that decision is so complex that not even the security people are likely to know it. And at that point, you've identified a problem and you can work on fixing it. If you want to get a little more advanced, you can ask what threats exist to perception or understanding. Are we showing them information that's reliable? Are we showing them information that an attacker can spoof? And there's ways you can think about those sorts of threats in effective and manageable ways while you're threat modeling a new system. So to sum up, anyone can threat model, and everyone should. The skills, the techniques, the repertoire that are involved in threat modeling are things that can be learned by anyone who is smart enough to be writing code, anyone who is smart enough to be deploying and managing systems can learn these skills, can learn how to do these tasks. There's a lot of traps. These traps, I call them traps because I've seen so many places that have fallen into one or more of them. I've talked to so many software development leaders who have experienced these things, and as a result, they don't want to threat model anymore because they tried it and it didn't work for them. And those are real experiences. They're hard to overcome when someone has had the experience of trying something that didn't work. You've got to sell them on doing it again. But threat modeling is really one of the most effective ways, or even the most effective way, to drive security through a product, through a service, through a system. If you're not threat modeling what you're building, you're going to be finding new and interesting security bugs for a very, very long time. And so again, anyone can threat model, and everyone should. And so I'd like to encourage you to remember the 4 questions. What are you building? What can go wrong? What are you going to do about it? Did you do a good job? I want you to go out and be proactive. Find security bugs early, fix them before people start to take advantage of them. And I'm hopeful, I'm optimistic that the tools that I've given you here today can help you drive threat modeling through the organizations that you work for, through the organizations that you work with. So to close, this quote from George Box: "All models are wrong, and some models are useful." I would encourage you to focus in on the useful kind. And with that, I am happy to take questions. Thank you very much. We've got someone with a mic running down right now.
Is it me, or did you just threat modeling, listing a series of threats and some mitigations?
Shh, that would be too meta for me. Anyone else?
When is the right time to do threat modeling?
So when is the right time to do threat modeling? You're never done threat modeling. No. So I like to threat model early. I like to say when people are starting to conceive of this is the software we're going to build, I like to threat model and go breadth first. I like to say what are the general threats we're going to encounter. And then as people are working on some feature, I like to go deep. So when you're working on the authentication system is the time to think through how we're going to mitigate the spoofing threats, what threats to those occur, and especially in an agile world where you might be doing test-driven development or some other lean methodology, you can work through what else you need to work on as you're developing that component. And so breadth early, depth later. And then at the end of the project, as you're getting ready to deliver or finish a sprint, you say, did we do approximately what we wanted to do in this sprint? Did we make changes to trust boundaries? No? Good, we're ready to go. And that can be a 5-minute thing at the end. It doesn't have to be a big complex thing that you do once. And if you break it down into the different component skills and the different tasks, it becomes more and more a part of development or more and more a part of system deployment rather than a discrete, when do I do this?
Hey, Adam.
Hey.
So the one thing I think is difficult in defense is feedback. It's really hard to check your work because you're not throwing shellcode somewhere, you can't tweak it afterwards. And it's the same problem with threat modeling. You do it once and you think it's right, but there's no real feedback into have you done a good job. So I'd love to know your thoughts around that. How do you kind of check your threat modeling?
So there's two aspects to that. The first is quality assurance. I think of testers as a natural ally to security. Testing is all about what can go wrong. And so oftentimes you can train testers, and this is something we found at Microsoft, is that our testers make great threat modelers. It's just another way for them to plan to find bugs. And so that's one way, is do your testers find things that your threat modeling approach didn't predict? If they do, then you need to work on your approach. The other thing is the check your work as you're done. If you created some sort of diagram of this is what we think we're going to build, this is where we think the trust boundaries are going to be, did you produce that or did you produce something different? So you can validate that your threat model matches your real software, and you can validate that your threat model predicted the sort of bugs that you ended up finding. And here's a place that pen testing can be super useful. If you have black box pen testers who come in, they find a bunch of bugs that totally disjoint from your threat model, that probably means your threat modeling activity, you need more training in how to find threats and how to predict them. If your pen testers find a bunch of threats in the areas that you predicted were going to be problematic, well, why didn't you control for those threats as you were building the software, right? What broke down along the way? Your threat modeling was good, but there was a disconnect between threat model ideation and development activity. So where was that? Is that helpful? Yes. Do a what? So the question is about avoiding repeating the threat analysis. And I think the answer there is, the answer relates a lot to the maturity of your testing activity. And I'm a big fan of the agile test-driven methodologies where testing is a key part of how you develop. And at some point, it's a matter of skill development that the first time you go through this, you're not going to be as natural or as fluid as the 20th time you go through it. And so, do you need to repeat is a difficult question without a lot of detail that's hard to do in a room like this. But I'm a big believer that if you find threats, you protect against them, you repeat the activity, you will develop skill over time. And developing that skill over time is something that takes that reflection. And so in your question, I heard some disappointment that you might be going through that. And I would caution you, it's natural to be disappointed, but it's also part of the learning process. If you somehow, sat a 6-year-old down and they're playing a Rachmaninoff concerto, the first time they pick up a violin, it is surprising and unusual. So treat it as natural. Treat it as, okay, we didn't do that to the best of our ability. Let's learn a couple of things. Let's do it a bit better next time and continue to iterate.
Threat modeling for non-specialists, we need an app for that.
We need an app for that. We might need an app. What I think we really need is the elevation of privilege game, which I created as a way to introduce people. It's available as a free download from Microsoft.com/security-SDL or something like that. And it's designed to help people get started in a non-threatening way that pulls people in and forces everyone in the room to participate. And the reason it's a physical card game, not an app, is because people get focused on what's in front of them. That same lesson from Kahneman is if you can look at your phone, you can go onto Twitter. If you've got these big physical cards in front of you, you have to look at the cards and talk to the people around you at the table. Not quite so good if you're on a distributed development team, but there's trade-offs in a lot of things in life.
Yeah. So I wanted to ask, which industry or which type of companies are mature enough today to do threat modeling, to buy threat modeling as part of what they're building?
I would look at it in a slightly different way. I would ask, what industries are so far from mature that they shouldn't try to threat model? And I think there the answer is I don't know of anyone who shouldn't try to threat model. You know, as people build more and more things which are internet connected, you need to start to learn how to do this. You need to make it part of your development activity in a way which is not someone coming in and saying, you must do this. It's get started, show some value, and make it so natural that the developers want to do it, in the same way that a lot of developers I work with would not write code without writing unit tests for it. I know developers who wouldn't start a project without threat modeling because they've seen what happens when they do that. And so I think that everyone should get started. It's why I created the game, it's why I wrote the book, is because we're at a stage where we need to be doing this. It's not, we're ready to do this. It's, if we don't do this, we're going to continue to have big trouble. So let's get started.
So the reason I am asking is because we all know that many companies are going to avoid security as much as they can in the project cycle, because they will see it as an obstacle of getting there sometimes, unfortunately. And threat modeling seems like something that is very useful. I can see why it's useful and should happen as a security person, but I don't know today who is ready to pay to have this added service in the life cycle of a project. So this is the reason I am asking, and the question is more, is this part of the life cycle, project life cycle for certain companies today? Is it something that is coming?
So for example, at a company like Microsoft, it is absolutely bog standard. You threat model as part of what you're doing. It's also part of much, much smaller companies. Before I joined Microsoft, I did consulting work with a number of companies where ranging from an hour to a couple of days. And I think a lot of the question you're asking relates to return on investment, right? It's how much time does this threat modeling work take? How long does it take before it starts to show value? And with someone who's experienced, I've never personally been threat modeling for more than an hour with a new group before someone leaves the room to go start fixing a bug. And that seems to me to be a pretty manageable demonstration size. Most development teams will give you an hour to explore a new idea and say, does that do something? If threat modeling is, you're going to have to spend a week of falling into these traps, doing things that you don't understand, people will, the questions you're asking are absolutely natural, where no one wants to spend a week doing something they don't understand, they don't see the value. Most people, you say, give me 30 minutes or an hour and we'll see if it pans out. They'll be willing to experiment at that level. And so the trick is to find something important in that hour that causes them to spend the next hour, that causes them to spend the next hour. And when they're not getting value anymore, stop, pull back, say, great, we spent 4 hours, we found 4 really good bugs that would be hard to fix late in the cycle. We saved ourselves all of this time that if a pen tester had found this, it would slow down our shipping cycle because we had to figure out what to do. That's a win, and it gives you the opportunity to build in the next iteration, the next sprint, the next version. So when you're asking about how do you convince a company it's worthwhile, find the important thing quickly and then stop or slow down when you feel that you're getting resistance over the time investment. Don't feel that it has to be a week or a month-long project.
Yes. Thank you.
You're welcome.
We've heard quite a lot about threats and mitigations and fixing bugs. What's your take on accepting some risks? Because at some point you have to accept some risks because you can't fix everything.
Yeah.
It's the right place and time.
So mitigation, or what are you going to do about it, is a spectrum from accepting risk to making architectural changes. And I think the big thing I want to say about accepting risk is be careful about who you're accepting risk for. For example, we see with the credit card industry, there's a lot of shifting of risk. And shifting of risk is a business activity that makes sense, but you should be explicit about it. What risks do we own? What risks are we putting on the customer? What risks are we asking people to click a dialog box that's indistinguishable from, we would like to cover our butts, so please click OK to continue. But yeah, the idea of accepting risk, the risk trade-offs are something that you have to work through organizationally in terms of what risks are acceptable, what risks is the organization willing to accept, what risks is the organization not willing to accept. And that's a natural part of software development, right? All software has bugs, you ship with bugs, and that's an acceptable thing because you're adding features. Your new version is probably more secure than your last, even if you now know that there's more security issues that you're aware of. So yeah, there's a trade-off. It's a legitimate trade-off. You have to make it.
Okay, Adam, thank you. Please give him a round of applause.